Okay, so we're going to talk about torque and couples here. Now, torque and couples is just a kind of like an ending idea, a concept to go along with moments. And the idea is that we'll take a couple of minutes over this, won't take too long, and we'll look at what torque and what couples are. So first of all, I've got a block on a table, and imagine that this is the table, and you apply a force here on that block. Now if there's any friction in this, it will act like a pivot, and so what you'll end up having, if you apply that force for enough time, you'll probably get movement to a new position like this, where it's rotated and it's translated. It's got translational movement and rotational movement. Now that's all well and good, but what if you want just rotational? So in order to have rotational, we need a couple. A couple is, as the name suggests, two forces that are parallel but act in opposite directions. Okay, so they're parallel to each other, but they act in opposite directions. So in this case, I'm going to draw a couple of forces here. So they're equal in magnitude, and quite simply, they're equal in magnitude, they're parallel, but they are in opposite directions. Now, in order to understand the idea around torque, so that's torque, torque is essentially a leftover moment. Now, in the previous videos, we were looking at the idea about moments in equilibrium. So in equilibrium where anti-clockwise was equal to your clockwise. However, in this case, both of these forces are potentially, if we were to assign a pivot, anti-clockwise. So they're going to add together. So force over here and the force over here. We're going to add together as moments. Now let's assign a distance between them. So we've got a distance there, and an overall distance there. So we're going to call that one D. We'll call that D divided by 2, D divided by 2. So in order to work out this, we've got a force here times by the distance from a pivot plus the force here times the distance from the pivot. And that will equal our net moment. And as a result, we get rotation. Now we can simplify this quite significantly if I rewrite this as FD over 2 plus FD over 2. Well, you've got essentially half of FD plus half of FD. Well, that's just equal to F times D. And essentially what we've ended up with here is an equation that looks like a moment calculation on its own, but it's not. It's a torque calculation. Let's go through the key differences. The force is just the force of one of the couple. Remember that to be a couple, they have to be equal and opposite, but parallel. The distance is the distance between the two forces. So we've got some very specific differences here, where with a moment you might think, oh, I need to use all the forces. No, you just use one of the forces in a couple, and for the distance in this calculation, it is the perpendicular distance between the two forces. Okay, because bear in mind, these are at right angles. Okay, so the perpendicular distance between the two forces is the distance you should use for a torque calculation. Torque is just another name for net moment. Net moment will create rotation. rotation is torque. So that's it for couples and torque. You need to know the definition of a couple, the fact that they are equal in magnitude, opposite directions but parallel, and the fact that the calculation looks similar to a force times distance, which is the same as a moment calculation. However, we need to just bear in mind the key specific criteria. Again, the unit of torque would be Newton meters, the same as a moment. Okay. Have a look. There's some nice examples in the textbook of a worked example. Have a work through that. Add that to your notes. And you'll have some questions on the textbook pages as well to help you out. If you have any questions, bring them to class and we'll deal with them then.